So this is the second half of your review sheet, questions 11 through 20, and number 11 is what is the definition of continuity? So the first thing you need to remember for continuity is that the function has to exist at c. So f of c exists. The second thing is that the limit has to exist. So the limit as x approaches c of f of x exists. And the final requirement for continuity is that the limit and the function are equal to each other at point C. Question number 12. Identify all the discontinuities, if any, as removable or non-removable for this function. Let's go ahead and factor it out. We're going to get x minus 3 times x plus 2 over x plus 2x minus 9. So we're going to have two discontinuities. One is going to be at negative 2 because of this right here, and one is going to be at positive 9 because of this right here. Now the negative 2 is going to be removable because it can be canceled out. So we have a removable discontinuity at negative 2. 9, however, cannot be canceled out, so it is a non-removable discontinuity. Now 13 then asks which discontinuities in number 12, if any, are also vertical asymptotes. Well, if you remember, vertical asymptotes are the discontinuities that cannot be canceled out. So x equals 9 is a vertical asymptote. And just for your information, that would make negative 2 a whole. Number 14, find any discontinuities in this piecewise function. These are very simple to do. Just find the number where they connect, which in this case is negative 2. Plug them into the top and the bottom and see if they match. So if I plug it in top, negative 2 squared is 4. 4 times 3 is 12. 12 minus 4 is 8. So I get 8 on top. When I plug it in the bottom, negative 2 plus 1 is negative 1. Okay, these two numbers do not match. So that means they don't meet at negative 2. So there is a non-removable discontinuity at x equals negative 2. Piecewise functions are almost always going to be jumps, at least ones that are set up this way. So that's why they're non-removable. 15. Find any horizontal asymptotes for the function. Well, when you find horizontal asymptotes, you need to consider the limit as x approaches positive infinity and as it approaches negative infinity. Okay, so as we approach positive infinity, we notice that the power is bigger on the bottom. So since the power is bigger on the bottom, the answer is 0. And actually, that's true down here as well. As we approach negative infinity, the power is bigger on the bottom, so we get a limit of 0. So there's just one horizontal asymptote, but it's horizontal asymptote at y equals 0. But there will be times where you may get different ones. A lot of times they're the same, but sometimes they're not, so it's good to check both sides. 16. Find the limit as x approaches infinity. Okay, well, if we look on top, our biggest power is x cubed. On the bottom, it's x squared. So since the power is bigger on top, the limit is infinity. And then it asks, what does this say about the function's horizontal asymptotes? Well, if the limit is infinity, we don't have any. We don't have any horizontal asymptotes. You can't draw a line at y equals infinity. That doesn't even make sense. So if we get infinity as our answer, that tells us we don't have any horizontal asymptotes. 17. Given the function 2x squared minus 4x plus 3, does the intermediate value theorem guarantee that for some c on the interval 0 to 3, that we would equal 10? Well, first make sure your function is continuous, and 2x squared minus 4x plus 3 would be. It's just a basic parabola, nothing weird, so it is continuous. So next we need to test out our f of a and our f of b. In other words, plug in our 2 points from our interval. So if we plug in 0, we're going to get 3. And if we plug in 3, we're going to get, let's see, 18 minus 12 plus 3. I think that's 9, if I'm not mistaken. Let me double check that. 3 squared is 9, times 2 is 18. 3 minus 4 is 12. 6 plus 3 is 9. Alright, so we did this correctly. So, since we have 3 and 9, does that guarantee that we'll pass through 10? No, it doesn't, because 10 is not between 3 and 9. So we would have to say no on this one. It's not guaranteed. It's certainly possible that the function goes up to 10 and then back down to 9, but we can't know that without more information. So we just have to say no, the intermediate value theorem does not guarantee this. 18. Given this piecewise function, find the following limits. So first, find the limit as x approaches 1 from the left. Well, if you think to the left of 1, that's numbers that are less than 1. So we will plug in 1 into the top equation. So 1 squared plus 2 is 3. Now for b, we're approaching 1 from the right-hand side. So that's where we are greater than 1. So we'll plug 1 in to the bottom equation. So 2 times 1 minus 3 gives us negative 1. Now c asks for the regular limit, meaning we have to consider both sides. Well, considering the fact that we got 3 from the left and negative 1 from the right, that means that they do not meet, so this means the function does not exist. Excuse me, not the function, the limit at that point does not exist, because you have to be approaching the same thing from both sides in order for the regular limit to exist. 19. Given this function, find a value of c so that f of x is continuous everywhere. Well, for these to be continuous, we need them to be exactly the same at x equals 3. So I'm going to plug 3 in the top equation. That gives me 6 minus 1. I'm going to plug 3 in the bottom equation. That gives me 3 squared plus c. And I need them to equal. So I get 5 equals 9 plus c, or c equals negative 4. So if c is negative 4, then this function will be continuous. Because again, to be continuous, they have to meet and thus be equal at x equals 3. Final question, the 3 reasons that cause limits not to exist. The first is differing behavior from the left and the right. That means that the left side approaches something different than the right side. Number 2 is that unbounded or infinite behavior, so it goes to positive or negative infinity. And the last one is oscillating behavior. Remember, that's where it bounces up and down all over the place. And that concludes your review sheet. Good luck on your test.